Hello everyone, we are students of VIT Andhra Pradesh. I am Gubbala Sri Ganesh with registration number 21 BEC 7184.
Hello everyone, I am Charan. My registration number is 21 BEC 7159. I am from group 3. We are going to discuss about question number 2.3.
My name is Vishnu Vardhan and we are being assigned to the third question in the second chapter, and today we are going to solve it. Thank you.
So here is the question 2.3. We are given an input x of n. X of n is 1 by 2 whole power n minus 2 u of n minus 2. And the unit impulse response h of n. H of n is u of n plus 2. We have to determine and plot the output y of n is equal to x of n convolution h of n. So here is the solution. We know that u of n is 1 for n greater than or equal to 0 and 0 for other conditions. That is u of n minus 2 is 1 for n minus 2 greater than or equal to 0, which means n greater than or equal to 2, and 0 for other conditions. If we multiply 1 by 2 whole power n minus 2 to this function, this whole function the value of this whole function is 1 by 2 whole power n minus 2 for n greater than or equal to 2 and 0 for other conditions. This is nothing but the given x of n. So we can plot the graph of x of n like this. For n greater than or equal to 2. So for n equal to 2 we have to substitute 2 here, which we get 1 by 2 whole power 2 minus 2 is 0. And for n equal to 3 we have to substitute 3 here, which is 1 by 2 whole power 3 minus 2, which is 1 by 2 whole power 1, and so on like this. So this is the graph of x of n. Similarly h of n is equal to u of n plus 2. So u of n plus 2, the value of this function is 1 for n plus 2 greater than or equal to 0, that is n greater than or equal to minus 2, and 0 for other conditions. So the graph of h of n be like this, from minus 2 to infinity. The value is 1. So this is the graph of h of n. We have to find y of n. Y of n is x of n convolution h of n, which is equal to summation k equal to minus infinity to infinity x of k h of n minus k. This is the formula. X of n convolution h of n is equal to summation k equal to minus infinity to infinity x of k h of n minus k. Now x of k, we know x of n. I have to just substitute k in place of n to get x of k. So we know here x of n. Just we have to substitute k in place of n. Similarly, like h of n, which is equal to 1 by 2 whole power k minus 2 u of k minus 2. This is the graph. And similarly, like h of k, this is u of k plus 2. This is the graph. Now we have to find h of minus k. H of minus k is the flipped graph of this h of k. So on flipping this graph, we will get this plot. Minus 2 becomes plus 2, minus 1 becomes plus 1, 0 will be remains same, 1 becomes minus 1, 2 becomes minus 2, and so on. And here 3 becomes minus 3, and so on. Now we have to move this graph by n steps, that is h of n minus k. On moving this we get n plus 2, n plus 1, n minus 1, n minus 2, and so on. That is, we are moving n steps, so we will get like this. On seeing the graphs x of k and h of n minus k, on seeing the graphs x of k, this is the graph of x of k and h of n minus k. This is the graph of h of n minus k. You can observe that this n plus the overlap of both the graphs starts from n plus 2 is equal to 2. When n plus 2 is equal to 2, the overlap starts. That is, when n is equal to 0, the overlap starts. unknown, see, we can observe that if there is infinity and there is infinity and overlap ends at infinity, and that means there is no ending of overlap. That is x of k into h of n minus k is not equal to 0 for n greater than or equal to 0. For n equal to 0, y of 0 is x of k into h of 0 minus k. X of 0. If we substitute n equal to 0 here, we will get 2, 1, 0. So we have to multiply each element. So here 2, here 2. The value of h of n minus k at 2 is 1, and the value of x of k at 2 is 1 by 2 whole power 0. We have to multiply both of them, and we will get 1 by 2 whole power 0 into 1, which is equal to 1. And similarly like this, y n equal to 1, y of 1 is x of k into h of 1 minus k. X of k is 2, 3 and so on, 1 by 2 whole power 0, 1 by 2 whole power 1. This is x of k. H of 1 minus k, we have to substitute n equal to 1. So we get 3, 2, 1 and so on. Here the value of x of k at 2 is 1 by 2 whole power 0 and at 3 is 1 by 2 whole power 0. And h of 1 minus k at 3 is 1 and 2 is 1. I have to multiply both of them and add. So that is 1 at 2 1 by 2 whole power 0 and at 2 1 1 by 2 whole power 0 into 1 and at 3 1 by 2 whole power 1 and at 3 1 by 2 whole power 1 into 1, which gives 3 by 2. Similarly like n equal to 2, n equal to 2, y of 2 is x of k h of 2 minus k, like that 1 by 2 whole power 0 into 1 plus 1 by 2 whole power 1 into 1 plus 1 by 2 whole square into 1, which is equal to 7 by 4. For n equal to 3, y of 3 is x of k into h of 3 minus k, which is 1 by 2 whole power 0 into 1 plus 1 by 2 whole power 1 into 1 plus 1 by 2 whole square into 1 plus 1 by 2 whole cube into 1, which is 15 by 2. Similarly, on observing a pattern, we can observe a pattern. So we can write in general y of n is 1 by 2 whole power 0 plus 1 plus 1 by 2 whole power 1 into 1 plus 1 by 2 whole square into 1 and so on up to 1 by 2 whole power n into 1. We can observe a pattern here 1 by 2 whole power 0 into 1, here for n equal to 0, here for n equal to 1 1 by 2 whole power 0 into 1 plus 1 by 2 whole power 1 into 1, for n equal to 2 1 by 2 whole power 0 into 1 plus 1 by 2 whole power 1 into 1 plus 1 by 2 whole square into 1. We can observe a pattern, and in general we can write y of n is 1 by 2 whole power 0 into 1 plus 1 by 2 whole power 1 into 1 plus and so on 1 by 2 whole power n into 1. On simplifying, we get 1 plus 1 by 2 whole power 1 plus 1 by 2 whole square plus and so on 1 by 2 whole power n. This is in a geometric progression, and we know the sum of n terms in geometric progression is Sn is equal to a into 1 minus r power n by 1 minus r for r less than 1. Here r is the common ratio, which is equal to 1 by 2 here, and a is the first term, which is equal to 1, and substituting we get this value, and finally 2 into 1 minus 1 by 2 whole power n plus 1 is the answer. Now we get the output y of n is equal to 2 into 1 minus 1 by 2 whole power n plus 1 u of n. This is the required output we got. So we have to plot this. So y of n is equal to 2 into 1 minus 1 by 2 whole power n plus 1 u of n. So we know this value of function is 2 into 1 minus 1 plus 1 by 2 whole power n plus 1 for n greater than or equal to 0. The value of this function is 2 into 1 minus 1 by 2 whole power n plus 1 for n greater than or equal to 0 and 0 for other conditions. So if we put n equal to 0 in this equation, we can, for n equal to 0, this value becomes 1. 1 by 2 whole power 0 plus 1 is 1 by 2 whole power 1. 1 minus 1 by 2 is 1 by 2. 2 into 1 by 2 is 1. For n equal to 1, if we substitute 2 into 1 minus 1 by 2 whole square, which is 3 by 2. For n equal to 3, 2 into 1 minus 1 by 2 whole cube, which is 7 by 4 and so on like this. For n equal to 3, we get the value 15 by 18. For n equal to 4, we get the value 13 by 16, and so on. So finally we got y of n is equal to x of n convolution h of n, which is equal to 2 into 1 minus 1 by 2 whole power n plus 1 u of n. That's the question number 2.3. Thank you.